Introduction to fault entry. NMDL software has the facility to identify unusual combination of relay and power supply status and pop up to the user for generating various exception reports. Fault entry software is special software for configuring the faults. By default, analog channel faults are triggered in NMDL when a supply voltage crosses its minimum and maximum limits. No entry is needed in the fault entry software for this purpose. New fault logics can be created using generalized logics entry, entering new faults. By default, there was 488 faults were predefined. Only inputs to the fault, timer values if any, and fault message have to be entered the relevant logics with fault entry software. To enter a new fault. Step 1. Open the fault entry. Step 2. Click on empty row in faults list. Step 3. Select the type of fault from fault type list. Step 4. Select the signals from signals list by double-click on signal. For getting all signals list, click on all signals button. Step 5. Enter the fault message and time interval if exists. Step 6. Click on Add to Fault List, save fault list and create output. Timer value. Timer value should be in terms of units, that is 1 second is equal to 100 units. For entering 10 second, 1000 have to be entered in this time column. Faults can be configured in 3 types of levels. They are important, medium and least. Depending upon the importance of the event, an entry level need to be configured. Level changing. To change level of fault, select the fault. Right-click mouse on it. A pop list will be displayed with delete and levels. Select level and select required level important for important fault, medium for medium level fault, least preferred for least preferred faults, and non-pop for non-pop faults. Faults were registered but not visible in online fault screen. Disabling a fault. To disable a fault, select the required fault. Single click on Y or N column. N will be displayed. If again pressed in the same column, Y will be displayed. For disabling the faults of similar type, select the fault type and click on Type. Fault entry screen options. DL or station name contains list of all station names in the network and in which station faults was entered or entering, available top of the screen. Faults type list shows the list of faults entered in the selected station. In that S number is shown the fault entry number. Fault name is type of fault selector. Fault message is message of the selected for identifying the fault in the NMDL online fault screen. Y or N is whether fault has been selected or not for processing or checking. LVL shows the level of fault. Signals list shows the list of signal names selected fault. Time gap shows the time interval value for the selected fault. Time interval value should be entered in units, that is, for every 10 millisecond it is equal to 1 unit. Signal name or input name. Name of signal selected from the list of signals. Fault type gives list of fault types, predefined and newly created logics. Fault message. The message to be entered for the fault to identifying the fault in NMDL. Fault condition shows the logic was implemented for the selected fault type. DL name from which station's signals are selected, available bottom of the screen. Is for enabling all faults for processing. Is for disabling all faults for processing. Is for enabling all the faults of similar type for processing. Is for disabling all the faults of similar type for processing. Is for changing the level for similar type of faults. After clicking the button, new form will be displayed. In that form, enter I for important faults, M for medium level fault, L for least preferred fault, and P for non-pop-up faults, and click on OK. Is for changing the time interval values for similar type of faults. Modify the time gap value and click on Time button. Buttons below the screen. All signal types, for getting all the signals for selected station. Add and save fault list, for adding and saving the fault which was selected to the grid in file. Create output, for creating output files for processing the faults in NMDL application. New logics, for creating new fault types with logics. View logic, for viewing the newly created fault logic. Enable only for newly created logics. Print to get the printouts for the entered faults. Close for closing the fault entry application. Route faults entry. Objective to add signals of particular route to the selected route. To enter the route faults, open the fault entry. Click on empty row in faults list. Select the type of fault from fault type list, route failure fault type. Select the signals from signals list. Enter the fault message and time interval if exist. Double-click on route in selected signals list. New form will be displayed. Enter the signal name, status, time gap and fault message. Click on Add for adding new signal name. Click on OK to add the route to the fault. To add signals in route entry screen, in first entry box in front of signal name. Select by click in signal name, right side of window in first entry box. Select and double-click the signal name from the list left side of window. Select statuses either up or down. Select type if visible. Click on Add button. Enter time gap if exist. Enter fault message 1. To add cancellation signals in second entry box in front of signal name. First enter signal name in first entry box. Click on second entry box and select the signal name. Select statuses, type and fault message 2. Click on Add button. To delete a record, select the record to be deleted. Click on Delete button. To insert a record, select the row where new record to be inserted. Click on Insert button. Modify delete a fault. Modify a fault. Step 1. Select required fault to modify. Step 2. Change or modify. If required, signal names have to modify. Select the required signal name and reselect from the list. If time gap or fault message have to modify, re-enter those values. Similarly for route and circuits also if present. Step 3. Click on Add to fault list, save to fault list and create output. Delete a fault. First method. Step 1. Select the required fault to delete. Step 2. Double-click on the fault. Confirm window will be popped with Do you really want to delete the record? If yes was selected, the fault will be removed from the grid from faults list. Step 3. To delete the faults permanently, click on Saved to fault list and create output. Second method. Step 1. Select the required fault to delete. Step 2. Right-click mouse and select Delete option. Confirm window will be popped with Do you really want to delete the record? If yes was selected, the fault will be removed from the grid from faults list. Step 3. To delete the faults permanently, Click on Save to Fault List and create output. Creating new logics. Objective: to create user-defined fault logics. To create new logics. Step 1. Open fault entry, then open new logic creation window. Step 2. Type fault type name in fault name box, which should not match with predefined logics. Step 3. Enter number of functions, number of timers, number of triggering signals, number of delete triggering signals. Step 4. Enter fault condition. Step 5. Select separate trigger checkbox if required. Step 6. Enter the functions in function order grid. Step 7. Select logic types in logic table. Step 8. Enter condition if exist. Step 9. Click on Save button to save and close the form. To get this screen, click on New Logic button on Main Fault Entry screen. Entry of inputs, triggering signals selection, delete triggering signals selection, timer values, and fault message can be done with Main Fault Entry screen. Screen details. Fault name. Fault type is to be entered in the box provided at the top, but this name should not exist in predefined fault. If this fault exists, error message "this fault name already exists, give some other name" will pop. Number of functions. Enter the number of functions excluding timer functions needed for the particular fault logic. Here, a function implies a task like checking the statuses of the signals, or checking a condition, or checking a route sequence, or displaying a message. For example, if 3 signals statuses are to be checked, if they all are down, first task, and along with that, if a condition that first signal down time is greater than second signal down time has to be checked, second task, then these 2 tasks become the number of functions. The functions have to be entered in the function order grid in the sequence in which they have to be checked. The number of columns in function order grid will be equal to the number of functions plus number of timer functions. Number of timers. Enter the number of timer functions required for the fault logic that is being entered. Number of triggering signals. Enter the number of triggering signals. The selection of triggering signals is provided in the main fault entry screen where the signals are entered for that particular fault. If all the signals are to be triggering signals, enter 0. Number of delete triggering signals. The number of delete triggering signals indicates whether fault have to proceed or not. It should not exceed the number of triggering signals. Once fault is executed, it will check all the functions. If the fault contains a timer, it will wait up to the timer exceed. If within the time interval the triggering signal status was changed, whether the waiting fault has to remove or not will indicate the delete triggering signal. If the triggering signal is selected as delete triggering signal, the fault will continue and check to next functions even though the status of signal has changed. If not, it will stop the processing of next functions if the triggering signal status has changed. Fault condition. The fault logic which will display in main fault entry form as help to entry can be defined in the box named fault condition. Separate trigger checkbox. Select this checkbox only if the triggering signal is a separate relay and not among the relays that are involved in the fault. On selecting this, the function order grid assigns first column for selecting the triggering signals logic. Select the status of the triggering signals by selecting the logic from the logic table. After entering all the above details, the function order grid is ready for entering the order of the functions. Enter the function numbers in the grid in the required order. The number of signals to be entered for logic itself is the function number. Functions description. Number of inputs. The number of inputs has to be entered for the logic function. By double-clicking on it, the logic table will be displayed. If n is number of inputs, then 2n rows will be displayed in the logic table. T specifies the timer function, C specifies the condition function, R specifies the root function, M specifies the message function. Logic table. If n is the number of inputs, then 2n rows will be displayed in the logic table with up-down combinations. For selecting the logic, double-click on correspond row in T/F. Column 1 will be displayed. If 0 is displayed, the logic has not selected. Example, if n equal to 3, then 8 rows will be displayed as shown. Condition entry. Objective: to enable the user to enter the conditions in the fault logics. This condition is also considered as a function number, so while entering number of functions, the condition function also has to be counted. If the function is C, then a grid appears for entering the condition. The values to be entered in each column will be present in the boxes at the bottom of the screen. To get this entry provision, enter C in the function order grid in the required position and double-click on it. About condition table, logic table. Initially, there are 10 columns in the logic table. Timer 1. Timer function number, depending on the number of timers selected in function order, that many timers list with T prefix will appear in the list. Bottom of the screen like T1, T2 and it goes on. Operator 1. Operators like smaller than, greater than, equal to, lesser than or equal to, greater than or equal to, by. Relay 1. Inputs sequence numbers. If 2 inputs are selected in function order, inputs will be x1, x2. x1 denotes first input and x2 denotes second input. DT UT1 denotes the time which have to select downtime or uptime, that is previous or present time of first relays. Operator 2. Operators like smaller than, greater than, equal to, minus, plus, smaller than or equal to, greater than or equal to. Creating new logics. Objective: to create user-defined fault logics. To create new logics. Step 1. Open fault entry, then open new logic creation window. Step 2. Type fault type name in fault name box, which should not match with predefined logics. Step 3. Enter number of functions, number of timers, number of triggering signals, number of delete triggering signals. Step 4. Enter fault condition. Step 5. Select separate trigger checkbox if required. Step 6. Enter the functions in function order grid. Step 7. Select logic types in logic table. Step 8. Enter condition if exist. Step 9. Click on Save button to save and close the form. To get this screen, click on New Logic button on Main Fault Entry screen. Entry of inputs, triggering signals selection, delete triggering signals selection, timer values and fault message can be done with Main Fault Entry screen. Screen details. Fault name. Fault type is to be entered in the box provided at the top, but this name should not exist in predefined fault. If this fault exists, error message "this fault name already exists, give some other name" will pop. Number of functions. Enter the number of functions excluding timer functions needed for the particular fault logic. Here, a function implies a task like checking the statuses of the signals or checking a condition or checking a route sequence or displaying a message. For example, if 3 signals statuses are to be checked. If they all are down, first task, and along with that, if a condition that first signal down time is greater than second signal down time has to be checked, second task, then these two tasks become the number of functions. The functions have to be entered in the function order grid in the sequence in which they have to be checked. The number of columns in function order grid will be equal to the number of functions plus number of timer functions. Number of timers. Enter the number of timer functions required for the fault logic that is being entered. Number of triggering signals. Enter the number of triggering signals. The selection of triggering signals is provided in the main fault entry screen where the signals are entered for that particular fault. If all the signals are to be triggering signals, enter 0. Number of delete triggering signals. The number of delete triggering signals indicates whether fault have to proceed or not. It should not exceed the number of triggering signals. Once fault is executed, it will check all the functions. If the fault contains a timer, it will wait up to the timer exceed. If within the time interval the triggering signal status was changed, whether the waiting fault has to remove or not will indicate the delete triggering signal. If the triggering signal is selected as delete triggering signal, the fault will continue and check to next functions even though the status of signal has changed. If not, it will stop the processing of next functions if the triggering signal status has changed. Fault condition. The fault logic which will display in main fault entry form as help to entry can be defined in the box named fault condition. Separate trigger checkbox. Select this checkbox only if the triggering signal is a separate relay and not among the relays that are involved in the fault. On selecting this, the function order grid assigns first column for selecting the triggering signals logic. Select the status of the triggering signals by selecting the logic from the logic table. After entering all the above details, the function order grid is ready for entering the order of the functions. Enter the function numbers in the grid in the required order. The number of signals to be entered for logic itself is the function number. Functions description. Number of inputs. The number of inputs has to be entered for the logic function. By double-clicking on it, the logic table will be displayed. If n is number of inputs, then 2 n rows will be displayed in the logic table. T specifies the timer function, C specifies the condition function, R specifies the root function, M specifies the message function. Logic table. If n is the number of inputs, then 2 n rows will be displayed in the logic table with up-down combinations. For selecting the logic, double-click on correspond row in T/F. Column 1 will be displayed. If 0 is displayed, the logic has not selected. Example, if n equal to 3, then 8 rows will be displayed as shown. Condition entry. Objective: to enable the user to enter the conditions in the fault logics. This condition is also considered as a function number, so while entering number of functions, the condition function also has to be counted. If the function is C, then a grid appears for entering the condition. The values to be entered in each column will be present in the boxes at the bottom of the screen. To get this entry provision, enter C in the function order grid in the required position and double-click on it. About condition table, logic table. Initially, there are 10 columns in the logic table. Timer 1. Timer function number, depending on the number of timers selected in function order, that many timers list with T prefix will appear in the list. Bottom of the screen like T1, T2 and it goes on. Operator 1. Operators like smaller than, greater than, equal to, lesser than or equal to greater than or equal to by. Relay 1 inputs sequence numbers. If two inputs are selected in function order, inputs will be x1, x2. x1 denotes first input and x2 denotes second input. dt ut1 denotes the time which have to select downtime or uptime, that is previous or present time of first relays. Operator 2. Operators like smaller than, greater than, equal to, minus, plus, smaller than or equal to, greater than or equal to, except by. Relay 2 inputs sequence numbers in terms of x1, x2 and goes on. dt ut2 denotes the time which have to select downtime or uptime, that is previous or present time of first relays. Operator 3. Operators like smaller than, greater than, equal to, lesser than or equal to, greater than or equal to. Timer 2. Timer function number. Depending on the number of timers selected in function order, which many timers list with T prefix will appear in the list, bottom of the screen, like T1, T2 and goes on. And or indicator whether is there next condition or not. If another condition wants to include with same sequence, select and or. Again, 10 columns will be added to the grid and will be displayed by scrolling the vertical scroll bar. Otherwise, select none in 10th column. There are 4 types of condition are available with 2 relay 2s. x1 dt greater than x2 ut, t1 lesser than x1 dt minus x2 ut, x1 dt minus x2 ut greater than t1, t1 lesser than x1 dt minus x2 ut greater than t2. Above specified conditions have to be entered in the logic as follows. Entered logic condition will be displayed at the bottom of the screen. Speed type logic can also select with using 4th type of condition. Like t1 by x1 dt minus x2 ut greater than t2. Here t1 denotes length of the track. T2 denotes the speed to allow in the Example 1 for creating new logic. Let us take the following example for building new logic. Fault name, blanking of signals for 3 aspects. Logic HECR, DECR and RECR are down for more than given time interval. For above logic, inputs equal to 3. Logic equal to down, 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 we can take 3 in one function or 3 are in different functions. Timers equal to 1. For above logic, fault name, blanking of signals for 3 aspects. Number of functions is 1. Number of timers is 1. Number of triggering signals are 3. Number of delete triggering signals is 0. Fault condition HECR, DECR and RECR are down for more than given time interval. Function order 3T. In logic table, select DN, DN, DN by double clicking of T/F column. Example 2 for creating new logic. Let us take the following example for building new logic. Fault name, fusing of signal DG lamp. Logic after DR is pickup if DECR is not pickup within the given time interval. For above logic, inputs equal to 2 into 1 plus 1. Logic equal to up and down. Timers equal to 1. For above logic, fault name, fusing of signal DG lamp. Number of functions are 2. Number of timers is 1. Number of triggering signals is 1. Number of delete triggering signals is 0. Fault condition. After DR is pickup if DECR is not pickup within the given time interval. Function order 1T1. For the first function, up logic have to be selected. For the second function is timer. For the third function, down logic has to be selected. Between two inputs, timer functions to enter for waiting in timer. Example 3 for creating new logic. Let us take the following example for building new logic. Fault name, root failure checking. Logic, button 1 and button 2 is pressed after time interval if signal is not glow. Then sequence will be checked. For above logic, inputs equal to 3. Logic equal to up, up, down and root. Timers equal to 1. For above logic, fault name, root failure checking. Number of functions are 3. Number of timers is 1. Number of triggering signals are 2. Number of delete triggering signals are 2. Fault condition button 1 and button 2 is pressed after time interval if signal is not glow. Then function order is 2T1R. For the first function, up logic has to be selected. For the second function is timer 1. For third function, down logic has to be selected, and fourth function is root, which can entry through main fault entry. Example 4 for creating new logic. Let us take the following example for building new logic. Fault name, timer relay setting less. Logic, the time difference between AJTR1 is up and AJTR3 is up is less than given time interval. For above logic, inputs are equal to 2. Logic equal to up, up. Timers equal to 1. For above logic, fault name, timer relay setting less. Number of functions is 2. Number of timers is 1. Number of triggering signals are 2. Number of delete triggering signals is 0. Fault condition is the time difference between AJTR1 is up and AJTR3 is up is less than given time interval. Function order is 2CT. For the first function, up logic has to be selected. For second function, condition function, have to enter in the following way. Column 1 is null, column 2 is null, column 3 is x1, column 4 is ut, column 5 is nil, column 6 is x2, column 7 is ut, column 8 is greater than, column 9 is t1, column 10 is none. Example 5 for creating new logic. Let us take the following example for building new logic. Fault name, speed of the train. Logic, speed calculation between track 1 down and track 2 down. Track 1 length was given. For above logic, inputs equal to 3. Logic equal to down, down. Timers equal to 2, 1 for length and 1 for speed. For above logic, fault name is speed of the train. Number of functions are 2. Number of timers are 2. Number of triggering signals is 1. Number of delete triggering signals is 0. Fault condition, track 1 is down, track 2 is down and length equal to track 2 length. Track 1 is triggering signal. Function order is 2CTT. For the first function, down logic has to be selected. For second function, condition function have to enter in the following way. Column 1 is T1, column 2 is by, column 3 is X2, Column 4 is DT. Column 5 is nil. Column 6 is X1. Column 7 is DT. Column 8 is greater than. Column 9 is T2. Column 10 is none. Data backup. Procedure to take data backup. Data backup is making a copy of the data available in a CD or DVD. To make available free space in the hard disk and to have a copy of the old data. To recover the PC into running to the last backed up point in case the PC crashes. The amount of data days, months, years that should be kept in backup depends on the policy of the railways. The data that should be backed up is of three types. Database files of C drive, NMRH, backup folder. Depending on the database file naming format YY, MM, DD, HH, N.GDB, after the required files are copied in the DVD or CD, excepting the database files that are required for reference, the remaining may better be removed to create free space in the hard disk. Fault configuration files of C drive, NMRH, fault folder. Station yard diagrams of C drive, NMRH, chart folder. A copy of item 2 and 3 above should better be maintained in the DVD or CD for backup. These folders should not be deleted from the drive. Flash RAM downloading software. The data logger by default displays the status of the relays and power supplies connected to it against default names. The database of relay contacts and power supplies connected to the data logger are first configured through NMDL software in the CMU FAS PC. Flash RAM downloading software is used for downloading this database into the data logger in the absence of serial port for connectivity. An USB to serial converter MOXA may need to be used between the PC or laptop and data logger. Setting up communication between Flash RAM software and data logger. Click COM Settings button to configure communication between Flash RAM software and data logger. Click Commands button to open screen for following options. Link check, setting DL time, getting DL time. Opening screen of Flash RAM. Displays the station names. Displays the number of bytes transferred to DL while online downloading. Tolerance to be placed in analog channel records. By default, it will display 10. Version number to be entered by user if card type of selected station is of 99 bar 2000 and 1 COM PR. Displays the progressing of online downloading. Displays the acknowledgements received by Flash RAM. Displays the messages for user. Selecting database. Click Connect DB button. Select required GDB to connect. Click OK button. Stations list. Flash RAM will list the station names configured in RH setup table in the connected GDB. DL selected. D signal or A signal or both tables is not available. D signal and A signal tables are available. If selected station is of SSI type, then SSI to DL will be selected automatically. User has to provide the ID of data logger to which that SSI was connected. Selection of download type. After selecting a station, then download type will be enabled. User has to select the download type. If selected station is a relay hut of common protocol type and offline was selected, then message will be displayed. Click Yes if data of selected relay hut is to be downloaded into a DL to which relay hut was connected. Click No if data is to be downloaded into relay hut itself. Then following screen shows prepare files for RTU database in DL will be enabled for this combination. If Yes is clicked in above message, then this option will be checked automatically, else it will be unchecked. User can change this selection by checking or unchecking it at any time before starting download. Basing on the selections made, number of records for relay types will be decided automatically basing on the following condition. Grouping of relay types. If relay types are available, then flash RAM will display them in default sequence as in data logger. Track, point, route, button, slot, signal, relay are the basic types with IDs from 1 to 7 are available in data logger for display. All other types will be grouped as relay by default, but data logger has provision for 16 by 32 relay types as per the selection made. Flash RAM will automatically identify the corresponding type ID in database for above specified 7 types and map them with relay type ID as per in data logger if found. Remaining types should be mapped manually by the user. For manually grouping the remaining relay types, click mouse in corresponding edit box. This will enable a button. On clicking this button, will open a form with all relay type names, which are used in the selected station only. User can select the relay types which can be mapped under selected group. User has to select a relay type among the relay types which are selected to map for this group, whose status is to be used for displaying the status of relays in that group in data logger. Relay type which was automatically mapped for selected group by flash RAM. Relay type which was already mapped in other than the selected group. Relay type which was mapped to the selected group. Relay type which was not mapped to any group. Relay type whose status will be displayed for the relays in selected group. Click Cancel button not to save the changes made in mapping. Click Map button to save the mapping information for the selected group. If a relay type is not selected for display status, then following message will be displayed. User has to click Yes button to continue downloading process with default values for status of this group. User has to click No button to select a relay type. Initiating the downloading process. Click Download button to start downloading process. Flash RAM will display the following message if it finds any unmapped relay types. Click OK button to continue downloading by mapping them to relay type. Click Cancel button to stop downloading for mapping them. Loading of relays analog channels of selected station will be started. Validations will be performed on the data it is loading. Any observations made will be displayed as following. This message consists of description of problem identified, information of records which lead to this problem, possible options for continuing or discontinuing the downloading process. These options will be made visible basing on the level of problem. Save to file button will be available with all messages. This can be used to save the message in text format for further analysis. Close button will terminate the downloading process. Continue button will continue the downloading process as per the conditions specified for continue. After loading required data, flash RAM will display the following screen with format for output file. Click OK button to initiate the output file creation. If station name was checked in the previous list, then flash RAM will display the following screen for station name. Input the value for station name and click OK button. If value for station name is not provided and OK is pressed, then following message will be displayed. Hence, Station name is mandatory if it is required as per the selections made. On successful completion of output file, following message will be displayed. Limitations. Availability of downloading service depends on the combination of asset type, card type, and downloading type selected by the user. Following are the type-wise limitations. Asset type. Flash RAM downloading is available for data logger, relay hut, SSI types only. Flash RAM downloading is not available for RPL data logger type. Card type. Flash RAM downloading is not available for relay huts and SSI whose card type is not of common protocol. Downloading type. Online downloading is not available for relay huts, SSI whose card type is not of common protocol. Offline downloading is not available for relay huts and SSI whose card type is not of common protocol. What is validation? To check the correctness of the digital and analog inputs and simulation diagram. Process of validation. Digital input. Closing the digital contact and observing corresponding indicating LED is lit on the data logger. Observe the corresponding relay name in the LCD panel on the data logger. Simulation diagram. Compare the simulation diagram with the operating panel and test each route by operating from the panel. This test can be done faster by running old data in offline mode. The inputs and the description is called database. It shall be ensured that the same database is provided at the test room. Analog inputs validation. Correspondence checking. Disconnect the supply monitoring wire near the supply and observe the supply value with description correctly displayed in the LCD screen of data logger. Voltage value calibration. Measure the voltage with calibrated digital multimeter and compare it with the value displayed on the LCD screen of the data logger. Master copy of inputs monitored at each station shall be kept in the test room. Master copy to be updated whenever inputs are changed. Railways to monitor non-operating inputs by monitoring fault alarms on daily basis. Approved circuit diagram for new installations and modification to existing installations shall have a contact nominated for monitoring of data logger. Validation of data logger shall be part of functional test. Documents required for installation, testing and commissioning. Approved front plate drawing of panel for drawing of yard simulation diagram. Route section plan for Siemens type panel for route locking and releasing indication. Selection table or TOC or RCC for implementation of route failure alarms generation. List of analog parameters to be monitored, analog inputs. List of relays to be monitored, digital inputs. In case of British type panels where sectional route release is provided, the details of route release relays are to be given. Power distribution diagram of the signaling system. Insert the disk labeled NMDL install shield in the CD drive. The CD will run automatically and the following NMDL software setup launcher screen will appear, and in that install NMDL setup options. To install NMDL setup in Windows 98 or 2000 or NT, click NMDL setup Windows 98 or 2000 or NT and follow the instructions. To install NMDL setup in Windows XP or 7, click NMDL setup Windows XP and follow the instructions. After the installation is complete, follow step 2. Install Interbase Click Interbase and follow the instruction. Update latest softwares updates the softwares and DLLs as present in exe folder of CD2, C drive, NMRH folder, C drive, NMRH exe folder, C drive, NMRH DLLs folder. Click Update latest software. To close the setup, click Close the setup screen. How to view fault reports. Objective: to view the faults already occurred in the stations. Output: report will be displayed depending on the selection of ID, levels, types and status. To get this option, open Report software. Click on Faults Report from the main menu or from the toolbar. To get the report, select the section control and station from stations list. Select From Date and Time and To Date and Time. If needed, select the sorting order. Select the fault level. By default, all the level faults are displayed. If any particular fault level is to be selected, Remain fault level should be deselected by clicking on the square box. Select fault types, either digital or analog. Select an item from status. If cleared is selected, user can get the report of only cleared faults. If recognized is selected, user can get the report of only recognized faults. If not recognized is selected, user can get the report of only not recognized faults. If all is selected, user can get all the faults. Select any type of faults from alarms category. User can get only faults related to that alarms type. If user wants to get all the faults, select All checkbox. After selecting required features, click on Show button to get the report. Fault Digital Report. Fault Analog Report. Summary Report. Report Format. Table Format. Graph Format. Summary Report with time details. Report Format without speed value. Report Format with speed value. Category-wise Summary Report. Report Format when group by station is selected. In this report, fault count, fault message, first occurred time, last occurred time values are displayed. Report Format when group by fault type is selected. In this report, fault type-wise fault count, first occurred, last occurred time values are displayed. Table Format. In this report, count values of selected fault is displayed in table format of each and every station. Graph Format. In this report, fault count values are displayed in pictorial format. Summary Report. With time, details without speed option is selected. In this report, fault count, occurred time values are displayed. Summary Report with time details when speed option is selected. In this report, for overspeed of the train faults, speed of the train value is displayed in brackets which are adjacent to each occurred time value. Summary Report with time details when category option is selected. In this report, fault summary is displayed based on categories which are defined by the user. If analog channel is included in the logic, Its value is displayed in separated column as shown. For each and every fault occurrence, previous fault occurrences list is also displayed. Previous fault occurrences time limit is configurable. SMS short message service of exception occurrence, data logger to concerned staff, requirements and features. Individual stations are to be equipped with data loggers to log the status of various signaling assets. All the data loggers shall be networked to a central place that is divisional headquarters in bidirectional mode. Data logger software NMDL at the central place CMU records the online status of all the station's assets. A GSM modem shall be connected to an additional serial port of the NMDL PC and the same shall be configured in NMDL. NMDL software processes the online station data from data logger network for exception occurrence. It will pop up an online fault screen with information regarding the current exception. In addition, NMDL software with SMS module enabled will send this current exception information as an SMS through the GSM modem to the configured mobile. This software has a configuration screen wherein user shall configure the details of staff, name, designation, mobile number, responsible station, types of exception for which to be alerted, etc. The above information needs to be configured for each and every fault for all stations in the network with the details of the corresponding staff who needs to be alerted. The responsibility of the railways is to provide a suitable SIM for the GSM modem and recharging it periodically for sending SMS. This involves recurring expenditure. Requirements: GSM modem with suitable SIM 1 numbers, a local GSM cell phone number in India with SMS text messaging enabled, additional serial port, PCI serial port card, SMS module in NMDL software, configuring the SMS entries in the SMS software. The following configuration options are available for this facility: employee name selection, station selection, the list of stations whose faults need to be configured, fault type selection, the list of faults which need to be configured, fault level selection, phone number entry provision. Following is a sample of the SMS sent on occurrence of a fault which is configured for SMS. Delhi Main: overspeeding greater than 15 km per hour at 12680 at dated 5/13/2011, time 12:1:47, 266. Limitations: sending of SMS about the configured failure from NMDL PC CMU shall be done as soon as the related event packets are received from the data logger network. Lagging of a data logger's data due to network failures may result in late sending of the failure SMS from CMU. Delays or inability in sending SMS caused due to non-availability of GSM network is the responsibility of the GSM network provider. The length of the SMS message cannot exceed 160 characters. Hence, messages exceeding 160 characters shall be sent as separate messages. Scenario: data logger logs all the relay, tracks, signals, points, crank handles and gates, status which are connected to it. Data logger send these statuses to central system located in test room of DRM office through communication media like RE cable, OFC and microwave channels. At central location, raw data from data loggers is received by central monitoring unit through FEP. This raw data is processed and stored in central server. The sequence of relay operations are monitored for various events, failures, and records this as faults in the database server. The reports software shall connect to the database server and generate reports like digital log of events, relay operation count, faults, analog events, analog graphs, data log states, etc. Functionality of auto-mailing facility. This facility offers configuring various types of reports, mail IDs, report durations for automatic mailing. For selected faults and for selected stations, fault report will be mailed automatically through the software to the designated mail IDs. Features of auto-mailing. Facility to configure either detailed report or summary report. Auto-mailing are available in following intervals such as daily. Report can be configured to be sent daily once according to the below selection. Present day faults report, previous day faults report. Weekly report can be configured to be sent weekly once according to the below selection. Present day faults report, previous day faults report, weekly, that is previous 7 days faults report. In addition, specific fault types whose occurrence in a station is more than X, configurable times only, can be configured for a mail. Below are the list of configuration options available. Data loggers selection, fault type selection, level of faults selection, report type selection, enter the to address, that is email ID, daily or weekly selection, report sending time, report configuration, summary reports, if configured for auto-mailing, will be in the following format. Softwares used for investigation. When an unusual incident occurs in a station, the root cause for the occurrence can be investigated from the data which is available at local data logger, local PC if available, and also at the Central Monitoring Unit CMU. In the local PC as well as at CMU, the unusual incident data can be viewed as textual reports in Reports software, Track offline simulation software with graphically view of station, Reports software for selecting the database file, Run report software. New screen will be displayed by asking Enter system name. Enter system name if data is in another PC. If database in the same PC, then press OK. If we select date-wise, then enter the date and time details and click Connect. If we select the database wise, then mention path of the .gdb file and click on Connect. Log of reports. Objective: to view the digital or analog signals change status information. Output: the change status of digital or analog signal S when the signal was changed between selected time intervals will be displayed. To get the reports, double-click on Reports, select the database and click on Connect to Report. Select Log of Events from sub-menu under Reports or Log of Report icon on the toolbar. Select the Digital in Functions option. Select the station name S from the list or all option for all station names. Select the required functions from functionals list. Select the From, To Date and time or daily report. Click on Show button. Modem link status report. Objective: to view the status of modem CD report. Output shows the mode CD status report for the selected station, date and time. To go to this option, open the reports software. Select the modem link status report sub-menu in the reports main menu. Select the station and click on Show button. Missed events report. Objective: for knowing the missing sequence numbers in the selected data logger. Output: the missing sequence numbers count will be displayed. To get the reports, open Reports. Click on General and select Sequence Miss. Select the section Control and Station and Date and Time. Click on Show button. Use-based replacement report. Objective: to get the reports for bulb, track, point machines about their terminating lifetime, working functionalities. Prerequisite: the entry information of bulbs, tracks and points should be available. To get this option, open Reports software. Click on Use-based replacement report sub-menu option in the Reports main menu. Bulbs. Objective: to get the report of lifetime and working of bulbs. To get the report, select Section Control and Station. Select Operation Hours option in Parameter. Click on Show button. Relays. Objective: to get the report of working of relays. Output: report with number of operation of the relay. To get the report, select the relays from list. Select the date and time. Select the number of operations. Click on Show button. Track offline simulation software. For selecting the database file, run Track Off software. New screen will be displayed by asking Enter System Name. Enter System Name if data is in another PC. If database in the same PC, then press OK. If we select date-wise, then enter the date and time details and click Connect. If we select the database-wise, then mention path of the .gdb file and click on Connect. Selecting station, date and time. Objective: to view the changed relay status in yard layout. Input: logged data should be available in the system. Output: the relay changes at selected time will be displayed in simulation map. To get this option, double-click on Track Off. Select the database. Click on Connect button. New screen with list of station names, data available date, selection option for date and time will be displayed. Select the station name, from and to date. Click on Start button. Options. First, to view the simulation from first. Stop to stop changes in simulation. Previous to view previous signal status. Continue to continue changes in simulation. Next to view the next signal status. Latest status to view the latest status of signals. Do's and don'ts while placing of equipment. Place the data logger equipment always in dust-free area, preferably in relay room. The minimum distance between the equipment and all four sides shall be at least 0.8 meter. Don't place it in battery room or any hazardous area. Data logger equipment should be mounted on a rubber bush or wooden straps based on the flow conditions to protect from the induced vibrations. Do not place directly on tiles or marble flooring when the equipment is installed or placed nearer to the rail tracks. Do's and don'ts while wiring and jointing. Make sure that all points wired must be soldered neatly at intermediate tag block if provided. Do not keep excess lead or excess strands while soldering joints. As far as possible, use pressure contacts like Wago, Phoenix, etc. No twisting or termination with nuts are allowed for any type of joints of input wiring and communication cable wiring. Generally provide 2 wires for negative looping for each relay track consisting of about 50 inputs. Do not keep more than 1 relay rack inputs in one loop. The insulation of communication or analog input wires should be properly peeled for the required length without damaging the copper conductor. Heavy cables like armored etc. should not be taken inside the data logger. Prepare wiring diagram before starting off wiring. Correct it after wiring is completed. Do not wire the relay contact already used for some other purpose to data logger. Do's and don'ts while selection of inputs. Ensure to select all yard related for simulation and false related for generating fault alarm relays. Do not leave or ignore any vital relays or inputs which are involved in finding faults and simulation. Wire the 230 volt AC or 440 volt AC monitoring near the distribution board. Not at the charges. Keep AC to DC converters at the source of supply. Do not keep the AC to DC converter boxes inside the data logger. Do's and don'ts while earthing. Use 8 square millimeter copper wire for connection of earth to data logger. Do not use binding wire or signal cable or multi-strand wire without lugs for earthing. Earth wire must be terminated only in the data logger nominated termination, where 10 square millimeter nut and bolt provided at left side bottom of the data logger. All internal equipment are connected to this nominated terminal. Connecting earth wire to charger or any other point of the data logger will not serve the purpose. Do's and don'ts while giving power supply. Provide sufficient number of protected power sockets for extending 230 volt AC to data logger charger, printer, PC isolation 232 box UPS. The input DC supply to data logger shall not exceed 29 volt. Use power cable with sufficient thickness gauge while wiring 24 volt DC supply when taken from IPS. It shall not be less than 8 square millimeter 64 strand 31 SWG. Do not use the wires used for relay wiring to wire power supply to data logger or other equipment. Connect selected 230 volt AC supply out of local up 80 down 80 standby generator which is used to power the signaling to data logger. Do not connect to data logger the local 230 volt AC supply since its quality is poor. Do's and don'ts while networking. Use standard cables like jelly field or twin twisted or telecom 0.5 square millimeter wires to connect modem and cable hut. Do not use ordinary switchboard cables or high gauge signal cables or non-standard loose wires. Measure the dB loss before connecting the cable to the modems in network. dB loss should not exceed more than specified. Ensure proper connectivity without causing loose connection by using Wago, Phoenix terminals or proper soldering. Use 1:1 isolation transformers to reduce the induced voltages on both ends of communication cable. Do not use conventional terminals disconnecting U-links anywhere in the communication cable. Use only screened cables, that is, cables from OFC room to data logger, local cable at the data logger. Earth the screen of the cables. Do not use unscreened cables. Do's and don'ts while documentation. After validation, make a copy of wiring diagram for digital and analog inputs for submission to the office for preparation of proper documentation. Note the termination particulars of communication cable up to the OFC room. Do not make any rough copies or scratches on original. Do's and don'ts for digital inputs. Check the non-working inputs periodically. Observe the chattering inputs, if any, in the report available in the CMU. Do not wire to spare inputs if existed input is not working. Do's and don'ts for analog inputs. Observe the voltages periodically for accuracy. Do not change multiplication factors in database. Use calibrated multimeters for measuring the results. Do not measure the readings at different points for one input. Make sure that all voltages which are terminated through fuse are properly rated or not. Do not use overrated fuses or non-standard fuses for protection. Observe the graph reports from CMU for better understanding the behavior of power supply. Do not depend only on the present values to confirm the behavior of power supplies. Do's and don'ts for networking. Verify the modem for continuous data transmission. Do not switch off the data logger for modem reset. Verify the modem LED indications in case of data transmission does not happen. Do not reset the modem by ignoring the LED status on its front panel. Reset the modem by only using keyboard of data logger. Removing the modem from its place for resetting purpose will not solve the problem. Maintain the communication cable noise-free. Do not run the cable via noise, creating equipment areas. Use only the least lined cable permanently for data logger purpose. Do not use the cable for any other purpose, even for temporary usage. Check the induced voltage between the communication cable conductor and earth. It shall not be more than 3 volt. Use 1:1 isolation transformers for reducing the induced voltages between communication cable and data logger or RTU. Do not use unscreened cable for connection of data logger to communication medium. Do's and don'ts for power supply. Periodically monitor the battery condition by switching off the power to the charger. Do not discharge the batteries deeply. Make sure the interconnections of batteries are properly screwed. Do not use different capacities of batteries in between. Connect the potential free contact of the charger to a digital input for monitoring the health of the charger from CMU. Verify the availability of charger in running power on time condition through the report. Periodically observe the DL health report for understanding the DL reset, if any. DL resets due to power fail, if observed. Find out deficiency of power supply. Do's and don'ts for general. Read the manual completely for understanding the system. Don't use excess length of cables in the form of a coil. Keep the front and rear doors of the data logger or FEP or RTU in closed condition. Don't connect printer or external modem while it is in on condition. Check for no loose fitments of cables, modules and the Euro connectors. Don't disclose the passwords to unauthorized users. Whenever a service or maintenance work is carried out on DC input supply, ensure that the connections are in correct polarity while reconnecting them. Don't connect power supply with reverse polarity. The following reports are used in maintenance of data logger. Electronics Data Logger AMC, visit checklist version 1.0. Analog channels calibration report. Troubleshooting of data logger network. Failure. Data not coming to FEP from data loggers. Unidirection, single direction. Modem in FEP is connected to the modem of the nearest data logger. If FEP not receive data from data logger 65 onwards, check for modem at FEP side or at data logger side hanging. Check for cable disconnection. Break between cable huts at data logger end and FEP end. Cable pairs may be wrongly connected at the time of maintenance. Check whether modem is getting proper voltage at FEP side as per IRS 99/2006 CI 4.2.17. Check for induced voltages in the cable. Fault. Data not coming to one of the ports of FEP from data loggers where bi- or tri-direction flow is available. Since data will be available at the FEP from other paths, it is difficult to find out the failure. If not periodically checked, failure will be known after data not coming from all directions. It is possible to know about the failure in each direction by looking at the data flow at the FEP or data logger. Check all 5 aspects given for checking fault between problematic FEP network port and the first data logger connected to it. After checking all the 5 points, still data is not coming, interchange FEP port and check. Fault. Data not receiving from particular data logger connected in network. In single directional network or in bi-directional network, if one data logger is not sending data or not responding to link check and the remaining all data loggers are sending data to FEP, then the possibilities for the problem, for example, from data logger DLID number 68, data is not coming to FEP, check the following. Whether the data logger is bypassed due to power supply failure to the data logger at that particular station. Check if data logger is bypassed due to hanging of the processor. Check if OFC channel is bypassed due to some failures. Fault. Data not coming from few data loggers sequentially. For example, if the data is not coming from the DLID number 68 to 71 in single direction network, check the following. Check the communication line cable between the data logger 67 and 68. Check the modem which is connected to data logger 68 from 67. Same way, check the modem at 68 which is connected to 67 also. Check the data cable connectivity from modem to data logger in 67 and 68. Check for cable pair reverse or break-in between 67 and 68. Fault. Data coming slow from network data logger. If you observe any data speed problems in data receiving from any particular data logger, check the following items. Check the cable for more loss, loose terminations and induced voltage between the data loggers where the data transfer rate is slow. Check the data logger hardware for proper functionality. Check the modem status, otherwise reset the modem from CMU to work normally. Fault. Data not available for particular period from particular data logger. Check where the data logger is getting reset. Check where the data logger is not transferring data to FEP due to link problems from long time. If data is coming in online for some time and lagging some time, the reason may be continuous linking and delinking of modems, line cable faulty or OFC channel noisy, induction, loose connection at termination or crosstalk online. heavy data duplicating due to cable fault or modem fault from data logger. Data logger resetting frequently. Line cables or data cables lose contacts in the modems. Remote reset of modem not working. Fault: remote reset of modem not working. From CMU, with the help of NMDL software, you can reset the non-working modem or hanged modem by pressing Modem Reset button in command menu by selecting appropriate data logger and the modem port numbers. If the modem reset is given from NMDL and still the modem is not getting reset, the reasons may be as follows. For example, the modem number MA4, which is connected to data logger ID number 74, is shown as hanged in the network. Unidirectional network. Consider the unidirectional network such that the first data logger connected to the FEP is data logger number 65 and the last is data logger number 83. That is, assume that the second end of network through microwave channel at DLID number 83 is not connected. Open the command menu in CMU software, select the FEP port to which the network is connected and select the station name at which data logger ID number 74 is situated. Press the modem reset button and select the port number of data logger to which the hanged modem is connected. In the case the link between data logger ID number 66 and data logger ID number 74 is failed, the command will not reach the data logger, thus the hanged modem will not get reset. After the recovery of the link only, the modem can be made reset. Bi-directional network. Consider the bidirectional network as shown in the diagram. Open the command menu in CMU software, select the FEP port to which the network is connected and select the station name at which data logger ID number 74 is situated. Press the modem reset button and select the port number of data logger to which the hanged modem is connected. In case of link fail between data logger ID number 66 and data logger ID number 74, the command will transfer from the second direction through microwave, but it will stop at data logger ID number 82. As there is no link between data logger ID number 74 and the data logger ID number 82 due to hanged modem at data logger ID number 74. So in this case, if we want to reset the hanged modem, the link in the first direction up to the data logger at which the hanged modem is present should remain in proper condition, that is, link should show the OK status. Similarly, if the hanged modem is MO3 instead of MA4, then to reset that modem, the link in the second direction through microwave should remain in proper condition. Conditions for link fails between modem to modem. Here, network is connected with two types of modems: internal modem, dual card modem; external modem, single modem. Functionally, there is no difference between these two modems. Physically, one type of modem will be connected externally and the other type will be connected internally. Internal modem card will be fixed in data logger Euro rack itself. One internal modem card contains two modems and is inserted vertically in the data logger. The top modem is always called as ANS, answer modem, and the bottom one is called as ORG, originate modem. External modems are used at data logger if data has to be sent in more than two directions. Reasons for modem to modem link failures: more loss in the cable, more noise in the line cable, it should be less than -40 dB, crosstalk over line cable, Bad insulation over the line cable. Induced voltage in between limbs in a pair should be less than 3 volt AC. More joints in the cable between cable hut to data logger. Rusty terminals used for terminating the line cable. Patch cards used for connecting the line cable in repeaters. Amplifiers used for short distances. Distance between modem to modem crosses more than 20 km. Two data loggers bypassed sequentially if cable is used as medium. Line cables or data cables lose connections at data logger. Dual modem card is not inserted properly with motherboard in the data logger. How to see the modem reset report over a period of time. Modem reset status report is available in the report software. By selecting the station and the port number view, the modem's link make and break counts. This report is very useful to identify the frequent link failures in the network. The wrong and right methods of line connections between two modems. Modem LED indications and their significance are given in this diagram. OH LED on, modem pick up the line. OH LED off, modem hangs up. HS LED on, modem connected in high speed. AA LED on, auto answer mode. TD LED on, receive data from local DTE. RD LED on, receive data from remote modem. CD LED on, modem detects valid remote modem. Health LED blinks, shows modem working fine. Not blink shows modem is faulty. RTS LED on, request from data logger for data transmission. CTS LED on, modem ready to transmit. Various problem in modem. In this, the OH LED is in off condition, which indicates that the modem is in hang condition, thus it should be made reset. In this, the HS LED is in off, indicates that modems are connected at low speed due to line noise. In this, the CD signal is in off state, indicates that the modem is not in link with the modem at the other end. Thus, modem connections should be verified. In this, the healthy condition of modem is indicated. The TD and RD LEDs blinking frequently, indicating the proper data transfer and receiving condition. Troubleshooting for data logger failure. Fault: data logger not working. Data logger is powered with 24 volt DC. The operating voltage to the data logger processor is 5 volt DC. Thus, the output voltage of the charger 24 volt will be converted into 5 volt DC internally in the data logger power supply module. In case of data logger not working, observe the following things. Check whether charger output is present in allowed range as per IRS S99/2006 or not. Check the 5 volt DC supply by checking the yellow color LED on the display card of data logger. LED on, supply on. LED off, supply off. Check whether processor is working or halted by checking the green LED on the display card. If not, check whether processor is inserted properly with motherboard or not. LED on indicates processor is working. LED off indicates processor is halted or hanged. Check whether 7-segment display is showing real time or not. Check whether input fuse for DC to DC converter circuit on power supply card is present or not. If all the above cases are satisfied, replace the processor card and power supply modules independently with new cards. Fault: data logger resetting frequently. Normally, data logger never resets itself if the installation is perfectly done. The most unwanted situation with the data logger is resetting. The common reasons for the data logger resets are due to loose termination of power connectors and other cables, AC input voltage to the charger fluctuating frequently between high to low and low to high, low gauge cables used for charger, load and battery, especially when battery and charger are installed in separate room, causing low voltage problems. Heavy noise created by any other equipment which is connected in the same 230 volt AC power supply input bus. Isolation problem between output voltage of charger and system earth. Fault: data logger hanged. Processor halted due to high voltage spikes. System rack is not properly earthed. Power cable terminals or links loose connection. Digital scanning troubleshooting. Fault: one relay contact digital is not scanning. The scanning circuit of one relay contact is shown. The optocoupler used in the digital input scanner card isolates each and every relay contact independently. The output will be connected to multiplexing circuit and then to microprocessor of data logger. If input is not scanning, then do the following procedure. Check the connectivity between relay contact and data logger tag block for wiring continuity. Check the relay contact which is used for data logger is properly working or not. Check whether flat ribbon cable is connected properly or not in between data logger and tag block. Check the connectivity in the flat ribbon cable. Verify the fixings of digital input scanner card for not operating input. Check all connector pins in the input scanner card. Fault: group of relay contacts are not scanning. Normally, every 128 relay contacts are connected to one data logger tag block. After 128, the next 128 inputs will be connected to one more tag block. Likewise, all the relay contacts are terminated in different tag blocks provided in the data logger rack. The simple way of connecting of the relay contacts to data logger tag block is shown in the figure. A set of inputs not scanning in the sequential order. Check the common loop ground negative of the tag block at T1 if 1 to 256 inputs are not scanning. Check the common loop ground negative of the tag block at T2 if 1 to 512 inputs are not scanning. Check the flat ribbon cables at corresponding tag block for proper connectivity connected towards data logger. Fault: relays randomly not scanning. If some inputs are not scanning randomly, check the following aspects. Identify the inputs which are not scanning in the total inputs. Check the common loops at the relay rack side. If common loop problem is at T3, the entire relays based on T3 joint will not be scanned by the data logger. If there is any common loop problem at T10, all the relays in the rack number 10 that are connected to the data logger will not be scanned by the data logger. Fault: relay contact chattering. Chattering of any relay contact will be observed in the status display in online. The number of contact and name of the relay will be displayed on the LCD display by pressing the chattering option. If one relay contact operates on or off more than 8 times in 4 seconds, the 8th time onwards it will be declared as a chattering input. In this situation, the data logger will not record the information further. Data logger will be monitoring that input continuously whether the input state change count come into the normal range that is smaller than 8 in 4 seconds. It will start once again recording the input. The most common reasons for relay contact chattering are insufficient input operating voltage to that relay, relay clip contact problem, relay contact provided to data logger malfunctioning, induced voltage in the wires connected to data logger from relay, dry solders in the tag block or at any soldering joints, relay contact scanning circuit faulty. Fault: more inputs chattering in a group. To identify this problem, observe the digital status display for continuous flashing of LEDs on the block display, provided on the front panel of display card. If the LED's flashing is related to one particular card, then follow the below sequence. Check the digital card status on LCD display for TF transistor fails. If TF found for any card, then remove the card and verify the transistor. Bypass the transistor, short emitter and collector of the transistor to confirm the card functionality. Thus, if the transistor is found to be failed by bypassing the transistor, the problem can be rectified temporarily. Fault: one digital input scanner card not scanning 64 inputs in a sequence. This figure shows the basic connectivity of one 64 input relay contact scanner card, digital scanner card. From tag block, one set of 64 inputs out of 128 inputs will be connected to one digital input card through a 64-pin Euro flat ribbon cable. The remaining 64 inputs of the same tag block will be connected to the other card with a separate ribbon. To find reasons for not scanning, check whether flat ribbon cable is properly connected between digital tag block and digital scanner card input, which is available at back panel of the data logger. Check whether the card is properly inserted into motherboard or not. Check the LCD display for digital card status option. If the display shows CF, it indicates digital card is not properly inserted. Remove the card and insert it properly. Then once again check the digital card status. If the problem is not solved, then change the card with spare one to confirm the card problem. If spare is not available, interchange with any other card available in data logger for confirmation. Note: all cards are interchangeable. The changing of cards should be done only during the power off condition of data logger. Analog scanning troubleshooting. In the analog Euro rack, the first analog scanning card supports 1 to 8 channels and is referred to as analog scanner card with controller. Next card supports from 9 to 16 channels and is referred to as analog scanner card without controller. To support further 16 channels from 17 to 32, we need to have one more set of with controller and without controller cards. All the voltages are connected through protection strip only. Protection strip is a termination PCB in between the voltage source and the data logger. Connection of 16 voltage sources connected to the scanner module through 2 protection strips is shown in the figure. Based on the type of voltage to be monitored on the protection strip, one jumper selection has to be selected. Analog data packets are created in the analog scanner with controller card unit and transferred to the main data logger through 9 to 9 pin analog communication port. A packet is generated when the value changes by 5% of the nominal value of the voltage. An analog fault packet is generated when the value crosses lower or higher limits set by the user. Fault: Single channel voltage is not scanning. This block diagram shows different stages involved in the scanning of one voltage value. Check the input voltage at AC to DC converter box. AC voltage should be present. Check the input voltage at protection strip. It is a DC voltage. Check the voltage value selection jumper on protection strip for continuity. Check the fuses at AC input, at converter and at protection strip. Up to here, if it is OK, then check by replacing it with a new card. Fault: first set of 1 to 8 voltage channels is not working. First, check the input voltages at protection strip. Check the fuses in the protection strip. Check the flat ribbon cable for connectivity with scanner card. Fault: first set of 9 to 16 channels is not working. Check the input voltages at the protection strip. Check the red LED indication for operating voltage presence. Check whether the card is properly inserted or not. Check the flat ribbon cable for connectivity with scanner card. Remove the card and check the internal fuse in the power supply side. Fault: first set of all 16 voltage channels are not scanning. Check the LED indications on the analog scanner card with controller for problem identification. Green LED TX data transmission to data logger. Yellow LED RX data receiving from data logger. Both TX and RX LEDs should blink continuously if the data is transmitting to data logger. In case if any abnormality is found in the LED indications, please continue further checking. Check the input voltage to the scanner cards, whether it is present or not. Check whether serial communication cable between analog cards and data logger is properly connected or not. Check the input fuse with controller scanner card. Check the correct functioning of serial port of data logger by using another analog serial port available in the data logger. Fault: analog voltage value showing less or more. Verify the analog database according to the connected values through the option provided in the LCD. Verify the connected voltage values with analog database present in data logger by looking into each channel on LCD through the keyboard option provided. Verify the multiplication factor, particularly if the voltage value is OK. Check whether circuit is loading any input voltages. Confirm the analog voltage values loaded in data logger and those entered in the analog database in NMDL are similar or not. Note: the difference between the voltage value displayed on LCD and the voltage value printed or available in computer online menu can be up to 5% of the nominal value of the voltage source. 11.5 volt for 230 volt source. Cable configuration for analog connectivity. The cable connectivity between the analog scanner card and the data logger serial port is shown. How to troubleshoot network failure of a data logger. Packet generated in data logger A is sent to data logger B, but data logger B not able to receive it. If the data is not going beyond data logger B, failure may be due to transmission medium failure or data logger B failure. Whether communication medium is working correctly or not can be found out by bypassing data logger B. Bypassing is done by looping of transmission and reception pairs of cables at data logger B. If the communication medium is alright, the data of data logger A is received to data logger C directly. Further, this data reaches test room via data logger C. To conduct this test, two persons are required, one at data logger B and the other to observe the data at CMU in the test room. If data of data logger is coming to test room in multiple directions, data paths of other directions are to be disconnected at the FEP in the test room while observing the data in the test room.